All right, so for this example here, we are going to write the inequality and then we're going to solve. Okay, so what does this represent? I kind of have a mirror of it right here. I already constructed it on this side. All I'm missing out is that little line that goes right here. It's the line here, but it's an inequality and it says that with it is greater than symbol. So what are the three x's? Well, that's going to be 3x plus 5 is greater than. These are negative, so -4, and that's what we're solving for. Okay, just using the tiles. I'm going to go ahead and do it concrete. I'm going to use C for concrete, over here A for abstract. So I will work it alongside while I'm working them out. And since you've already done equalities, equations, right? Equal, the ones that are equal, the equal sign ones. You should be able to follow me with the steps because we already kind of did this. We're just now incorporating the symbol, the inequality symbol. So again, I don't want that 4. That 5, so I'm gonna make a copy, but I'm gonna make them what? Negative. But what I do to one side, I gotta do the other, because if you're gonna add -5 to one side, you better add -5 to the other, or you're gonna remove from one side, you have to remove from both. It's like lifting weights. And these guys will all cancel out. We kind of know that already. One of these cancel out. Nope, they're not 0 pairs. So now I got 3x equals to -9, all right? And now I'm gonna model my division. And you ask, so when do we model division like this? It actually starts in 2nd grade. So you can go back and kind of do it this way with your students who still struggle with division. It's not that fact that they can't divide, it's just they have a hard time with the concept of division. That's the key, the concept. So then I did add that -5 to both sides. Here's -5. Cancels, I bring down that 3x is greater than. Here, this was -9. This cannot be +20, cannot be +9. It has to be what? -9. This is where we have the hardest part. This is where we struggle with our students, because if we don't teach it conceptually, we lose them, right? So they get lost in the rules, right? If I throw so many rules at them, they forget. We're the adults. We remember rules like that, right? But they're still figuring this stuff out. Remember, they're not 30. They're, maybe 12, 13, 14 years old. They're still struggling with this. So x would be equal to -3, but in this case, it's what? X greater than -3. Over here, do the division. Do the division. When we do this, it does not cancel out. 3 divided by 3 is 1. It's just really 1x. It divides into 1. So 1x is greater than -3. Okay, they struggle with these rules as well, division rules. Is it positive, is it negative? Till I look over here, I just divided the -9 into 3 equal groups. That's all this is. -9 divided into 3 equal groups. Those are 4th grade math concepts as well. So 2nd, 3rd, and 4th grade math concepts cover this, right? So go back to when they were in elementary so they can remember and understand the concept of what we're doing here. A lot of times it's not that they can't do the math, it's they never understood the concept of the mathematics. Here is 0. Here's -3, and then x is greater than that -3. So it's going to be open, and we're going to shade to the right. And there you go. Puro potato con gravy. Do the 0 rule test, right? I call it just the 0 test. Is 0 greater than -3? Is it to the right of -3? Yes, it is. That is true. We got the right answer when you check. Easy stuff, guys. Concrete, abstract. You can mix it up, pictures, abstract, everything. I, for example, like to go concrete and abstract with virtual manipulatives.